Now I'm going to walk you through some of the basic techniques to handle outliers. One of them is trimming. The idea is very simple, just remove them. So for example, let's say this is your temperature reading right here, and these are your outlier values. Let's say minus 40, 56, 89, these are your outlier values. You can remove them completely, just remove them, and this is what you're left with. So this is one solution. Another solution would be just drop those rows that contain extreme values. For example, they could be because of data errors. For example, negative height or maybe impossible values. So in that particular instance, you can just drop them. So in this particular instance, you can see that you have an age minus 12. Well, that's not possible. So you can just drop this row. But it is essential to carefully consider the percentage that you're dropping, the percentage you're trimming, because you do not want to remove too much data. The third technique is capping. Another name for that is vinsorization. So suppose this is the data given to you. So in this case, what you do, you actually find your, let's say, fifth percentile and 95th percentile. Let's say this is my fifth percentile and this is my 95th percentile. So in this instance, you take this outlier value. Let's say this is the outlier. You just cap that. So you change minus 40 to 1. Okay, this is it changes to 1. Likewise, this 56, 58, and 89, they become 5, and this is what happens over here. So this is called capping. So in other words, you're replacing your extreme values with the nearest acceptable boundary. This one is an acceptable boundary. This is towards the boundary line right here, these ones and these two data points. So this is best for preserving data size, because you can see that since we are not deleting anything, we are just changing the row, so your data size is same. So one advantage of capping is that it avoids complete removal of outliers. Instead, what it does, it modifies their values to align with the nearby observation. And also, it helps you control the impact of outliers at the same time retaining their presence in your data set. Another technique is imputation. The idea is this, that you replace your outliers with a more typical value. For example, it could be mean, median, or mode. So suppose this is your reading, this is a temperature reading. And in this case, let's say this is the outlier, minus 40 and 56 and 89. So in this particular instance, if you want to replace with the median value, you just find the median of the data set and replace that with this median value. Likewise, and so in this case, your minus 40 will get replaced by median, and same thing with 56, 89, they'll get replaced with the median value. Or if you want, you can do with the mean value. So you have median or mean. That's what this M stands for. It's the mean or median value. Let's say you have a shoe size. So these are the shoe size of people, and then you have this outlier value 21. Okay, then you have 26, you have 89. In this case, you can replace with more common value, most frequent value. In this case, 2 is the most frequent value. So in this case, 21 will get replaced by 2, and 26 and 89 will get replaced by 2 right here. So this is best for small data set where every single record it matters. Another technique would be flagging outliers. In other words, you create a new binary columns. For example, let's say you create a column called is outlier, and this value is going to be either 1 or 0 depending on whether that record is an outlier or not. So for example, in this case, this one right here, just see age right here. So you can see that age is 23, 29, 51. Then you have 98 right here. So in this case, what I did, I created a new column called is outlier. And in this particular instance, this is normal. So that's 0, 0, 0. But this one is 1 because this one is an outlier because of this. So in this way, you can keep information about outliers without deleting them. So, in summary, this is what you do. You ask yourself this question: is it a data error? Well, remove them if it is. Is it rare but valid? Well, in that case, keep them. Is it hurting your machine learning model, your AI model? Well, in that case, you want to transform them or cap them. Well, is it the target case? Well, in this case, you definitely want to keep it. Is the model sensitive to your outlier? Well, in that case, you want to handle carefully. If you believe that your model is robust to the outlier, well, then you can ignore your outliers.